Hi everyone, I'm Kaushik and today I will explain the OWASP top 10, the second vulnerability called cryptographic failure. So what are cryptographic failures? They happen when sensitive data is not properly protected with encryption or when encryption is used incorrectly. Earlier in 2017, this was called sensitive data exposure because the focus was on symptoms like data leaks. But in 2021, OWASP renamed it to cryptographic failures to focus on the real causes like weak, missing, or broken cryptography. We can see why this cryptographic failures was ranked A2 in 2021 and A3 in 2017. In 2017, this issue was ranked A3. Why? Because it focused only on data leaks, not the actual crypto mistakes. And many teams thought we use HTTPS, so we are safe. But no one checked algorithms, key handling, or randomness. And testing was also in surface level, like they are just asking is HTTPS enabled instead of checking TLS versions, certificates, or weak chippers. And many crypto bugs were hidden under other categories like broken authentication or misconfigurations. But in 2021, things changed. OWASP shifted to root causes like weak algorithms, poor key handlings, and missing encryptions. And security tools also improved, like detecting TLS issues, weak hashes, and hard coded keys. And testing scope becomes broader, checking both data at rest and in data at transit. And many real breaches like weak password hashings, TLS downgrade attacks raised the awarenesses. Because of these, cryptographic failures moved up to second place in 2021. Now we can discuss about types of cryptographic failures. There are many types, but the main ones are data not encrypted, weak algorithms, poor key management, insecure transmission, and weak random numbers. So the first one, data not encrypted, which means sensitive data like passwords, records, or credit card numbers are stored or sent without encryption, like sending login credentials over HTTP instead of HTTPS. If it get hacked, attackers can see everything directly. And the second one is weak algorithms, which means even if data is encrypted, using old or weak algorithms makes it easy to break, like using MD5, SHA1, which are easy to break. So the third one, poor key management, which means encryption is only as strong as how you handle the keys, like hard coding keys, reusing the same keys for years, which leads to the cryptographic failures. And the fourth one is insecure transmission. It means data is exposed while moving over the network, like using old TLS versions or apps accepting invalid certificates. And the fifth one, weak random numbers. It means bad randomness makes keys, tokens, and session IDs predictable. So all of this make it easier for attackers to steal, decrypt, or tamper with the data. Now we can discuss some real world examples of cryptographic failures. First one, plain text storage. Some companies store passwords directly as plain text in their databases. It's a bad practice. If hackers get into database, they can see all passwords immediately without needing to crack them. And the second one is weak hashing. Some old systems use SHA1 for password hashing. It's bad practice. SHA1 is fast and not designed for password protection. If attackers use rainbow tables or brute force to crack millions of hashes quickly. And another example is hard coded keys. Developers sometimes put encryption keys, API keys, or tokens directly in the source code. So it is also a bad practice. If a company accidentally pushes source code to GitHub with a hard coded database password, if any attackers finds it, they gain full access to the database. And the last example is TLS downgrade attacks. If an attacker forces a secure connection to fallback from TLS 1.3 or 1.2 version to an older version, like which is insecure protocols like SSL version 3, or TLS 1.0 versions. It's a bad practice. So older protocols have their known vulnerabilities, so making it easier to intercept or modify the traffic. Now we can see how to prevent the cryptographic failures. The first one, data classification. First identify which data is sensitive, then don't keep it longer than necessary. If you don't need it, delete it. And the second one, precautions for data in transit. Always prefer TLS 1.3 which HSTS and disabled old or weak chippers like SSL version 3 and TLS 1.0 or 1.1 versions. Always validate the SSL certificate. This prevents the data in transit. And precautions for data at rest. Encrypt sensitive data with strong encryption. And encrypt not only the main database but also the backups and logs. These steps prevents the data in transit. And precautions for password storage. Never store passwords in plain text or reversible encryption. Use bcrypt, scrypt, and always add the salt, which is a random value added before hashing to prevent a rainbow table attacks. And the precautions for key management. Store keys in a key management service and rotate keys regularly. Never hard-coded keys in your code or config files. And precautions for algorithm choice. Avoid outdated algorithms like MD5 SHA1 and use modern and tested cryptographic libraries like SHA-256. And the precaution for randomnesses. Always use the cryptographically secure random generators. They generate unpredictable numbers. These are all the precautions for cryptographic failures. Hope you guys understood the cryptographic failures topic. Thank you.